This problem we are going to be solving a Robinson Crusoe economy, island economy, Cobb Douglas problem. So let's begin. Now the first step to solving this kind of problem is to find our production possibility frontier or PPF. So let's begin. Finding our PPF is very simple. First step is to write down our PPF equation, which is as follows. You need to memorize this one. Lx plus Ly equals the endowment of labor. And it so happens that we know our endowment of labor. It's right there. It's given. So we're going to plug that value into here. Okay? So let's do that. Let's plug in our value. Let's write this down. We have endowment of labor of 100. And sorry, that's actually 100. Okay. So we got endowment of labor. Now we need to find Lx and Ly. So let's find Lx and Ly. Finding Lx and Ly is very simple. Okay. So we have our production functions here, and we're going to use this production function to find our Lx and Ly. Okay, so let's do that. Let's find our Ly first. So our production function equals y for Ly. Let's solve for Ly. We divide both sides of the equation by 4. So we're left with y over 4 equals Ly. So we got our Ly right here. Okay. Now let's find our Lx. So we have a production function of x equals 5 Lx. We divide both sides of the equation by 5 and we get equals Lx. So we got our Lx here, right here. We're going to plug that into here. And we're going to plug Ly in here. Okay? So let's do that. That way we can, let me do some erasing here because we got a lot of things going on here on this screen. So let's do that. Okay? So our Lx is x over 5. Our Ly is y over 4. Perfect. Outstanding. Okay, I'm just doing erasing here. That way you don't get confused. And we know our endowment of labor. Our endowment of labor is 100. So let's write that down. So now we got these fractions, and in our PPF we don't like fractions. Okay, we need to get rid of them. Okay, let's get rid of this fraction. Let's multiply both sides of the equation by 20, and that should get rid of that fraction. Okay. Okay, so this becomes 1, that becomes 4, right? So we're left with 4x, right? That becomes 1, that becomes 5. So we're left with 5y, right? This the 100 times 20 equals 2000, right? Perfect. See, we're making progress here. Let's erase this. Making a lot of progress here. Now, and guess what? This is our PPF. This equals PPF. Okay. Now that we find our PPF, let's move on. That was the first part of the solving the problem. That was the first step actually. Okay. Let me rewrite our PPF here. And let me erase this one over here. Okay. So what's next? Now we have a Cobb-Douglas utility function. Okay, since we have a Cobb-Douglas utility function, we need to find our, we call it here our product, our rate of product transformation, or we call it RPT in microeconomics. So we're gonna use this utility function, a Cobb-Douglas utility function, to find our rate of product transformation, or RPT. So let's do that. Okay, our RPT equals the following: is the partial derivative of the function with respect to x divided by the partial derivative of the function with respect to y. Okay, so that's a RPT. So as you can see, we're going to be using some calculus here. So let's find our RPT. It's not that complicated. Don't be afraid of calculus. Calculus doesn't bite. So our utility function is x times y. Utility function x times y. Okay. Now there's one thing I don't like about square root here. I always like to rewrite this square root as x by the power 1/2, y by the power 1/2, x by the power 1/2, y by the power 1/2. I always like doing that, okay? Because, I don't know, I just feel like it's easier, more organized, because now I know I'm going to be using the power rule of derivatives to solve this problem. So let me tell you what I'm planning to do here. That way you know what I'm doing. If you know the power rule for derivatives, so you know what I'm going to do. But I'm going to assume you don't know. Okay, here's what I'm going to do. I'm going to take this power here and bring it down here, and then I'm going to subtract 1 from this power. Now for the denominator, I'm going to take this power here and bring it here, and then I'm going to subtract 1 from this power. Okay, so that's what I'm going to do, and I just wanted to let you know ahead of time what I was planning to do. That way you won't be confused and wonder what the heck am I doing. So let's do that. So we have 1/2 times x, 1/2 minus 1, y minus 1 by the power 1/2, 1/2 x by the power 1/2, and y by the power 1/2 minus 1. Okay, let me scroll a little bit, that way we continue solving this problem. So what do we get here? So we have 1/2 x negative 1/2 y 1/2 divided by 1/2 x 1/2 y negative 1/2. Perfect. Now if you remember from algebra, we have a negative powers here. So the way we make them positive is by bringing this x, this variable, to the denominator, and bringing this variable here up to the numerator, and that's going to make those negative powers become positive. So let's do that. Okay, so we have 1/2 y 1/2 y 1/2 divided by 1/2 x 1/2 x 1/2, and guess what? Now we're gonna multiply this one times this one, and you know what happens. You know the rule, the algebra rule. We have powers, and you multiply them, you add them. So 1/2 plus 1/2, that's gonna become 1. So let's rewrite that. Okay, so got 1/2 y 1/2 plus 1/2, then we have 1/2 x 1/2 plus 1/2. You see, I'm going step by step, that way you don't get lost. I don't want you getting lost here. Okay, I want you to know exactly what I'm doing step by step. I'm taking you little by little. So that's going to become by the power 1 x by the power 1, and you had this fraction here, so 1/2 divided by 1/2, that equals 1, and since it is 1, we don't need to write it. Okay, so we have y on top and x on the bottom, and guess what, this is our RPT, and we just find it using basic calculus. Now that we found an RPT, we need to find our marginal rate of substitution for our PPF. Okay, so let me erase this here real quick. Let me erase this. I want to continue. We get some space here. Let me erase this. Okay, so our RPT, as we found out previously, it is y over x. Too simple, right? I know. Life is simple. Life is not complicated. Now we need to find our marginal rate of substitution for our PPF. And the marginal rate of substitution for a linear function is just the absolute value of the slope of the linear function. Let's find that out. What is the slope of this PPF? So this is our PPF, remember? So we're going to find the marginal rate of substitution for our PPF. So let's do that. I don't think it's going to be that complicated. So let's rewrite our PPF. Plus 5y equals 2000. Now we need to solve for y here. So I'm going to subtract 4x. Okay, so we got 5y equals negative 4x plus 2000, right? Okay. Okay, so let's continue. Let's continue solving for y. So let's divide both sides of the equation by 5. So y equals negative 4x divided by 5 plus 2000 divided by 5. So our equation, so our slope, we just found it. It's up right here. Remember, if you remember this, so that's our slope. Okay, now, and remember that our marginal rate of substitution is the absolute value of the slope. Okay, so our marginal rate of substitution equals 4/5. Okay, and that's how we found it. So that was very basic, right? That's basic algebra. So we have our marginal rate of substitution for the PPF, and it is 4/5, and we got our PT. Okay, and we needed this information, okay, to solve the problem here. So let me do some erasing. That way you continue solving this problem. I don't want to have all these things here. I just wanted to show you what I was doing for your own benefit. And I'm sure you know this. I'm sure you know how to do this. But I just want to make sure you know what I'm doing here. That way you're not lost. Okay. So we know our MRS, or marginal rate of substitution, right? It is 4/5. So we have a RPT and our MRS, right? So now the step that we need to do is to equate both of them. to each other. So let's do that. So it is gonna be y over x equals 4/5. Okay, let me erase this. And now let me rewrite that again here, just below our PPF. 4/5. Okay, and guess what? What do we have here? We have a system of equation. We have a system of equations, right? So the way to solve a system of equation is by substitution. Or you can do addition too. But I'm going to use substitution. Okay? So let's solve this system of equation using substitution. Okay? Let me erase some things here. Let's do that because I feel like we're almost close. We're almost there to solving this problem. It's not that complicated, trust me. I think that these microeconomics problems are very easy, and that's the reason I'm sharing my knowledge here. So here, let's solve for y. Okay, so we multiply both sides of the equation by x. We're left with 4/5. Okay, perfect. Now we know what y is. We're gonna plug that in here. We're using substitution, remember? 4x plus 5 4/5 x equals 2000. Excellent. Now we solve for x. We know this one is going to cancel with this one. So we're left with 4x plus 4x equals 2000. Now we got like terms. This is like terms, okay? When we add like terms, what we do, we add them up. Okay, we add those two up. So we're left with 8x equals 2000. Divide both sides of the equation by 8. We're left with the following. We're left with 250. And guess what? We just found our optimal quantity of x that is going to maximize the utility of our consumer. Okay, now we need to find the optimal y, quantity of y that is going to maximize our consumer's utility. Remember from our previous equation that y equals 4 by 5x, and we got that here, right? So now in order to find y, we just need to substitute x into here. Remember, x equals 250. So let's do that. Okay. So y equals 4/5 times 250. Okay. So let me scroll down so I can get more space here to solve this problem. So 5 goes once and it goes to 50. So y equals to 4 times 50. So y equals 200. Okay, there you go. So we got optimal quantity of y that's gonna maximize the utility of this consumer is 200. The optimal quantity of x that is gonna maximize the utility of this consumer is 250. Okay, now that we know that, now we can actually find the optimal allocation labor to good X and good Y that's going to maximize the utility of this consumer. So let's do that. Remember our production function for X? It equals X equals 5 LX. Guess what? We know X now, so we're going to plug that in here. Okay, so it is 250 equals 5 LX. Now we're solving for LX. Divide by 5 both sides of the equation, and we get an LX of 50. That's the optimal labor allocation that is gonna maximize the utility of this consumer. Okay, it is 50 units of labor. Now let's do that same for the other, for good Y. Our production function for good Y was Y equals 4 LY. Now we know Y, so we're gonna plug it in here. So let's do that. Y equals 200 equals 4 LY. Divide both sides of the equation by 4 and we get 50 LY. Guess what? Now, in order to maximize the utility of this consumer, we need to allocate 50 units of labor for good Y and 50 units of labor for good X. So pretty much you gotta divide the units of labor equally between good Y and good X to maximize the utility of this consumer. That's all, and that's how you solve this problem. Now I hope you like this problem. If you like it, please click like and subscribe. Have a great day. Enjoy.